Have you ever been in a coding interview, staring at an array or a string problem, and your mind just goes blank? Well, this is for you. We are about to break down one of the absolute most powerful patterns for solving those problems efficiently, the sliding window.
So, let's set the stage. You've got this huge, long list of numbers, and your task is to find the best chunk of it. Maybe that means the part with the biggest sum or the longest sequence that has some special property. Now, how do you do that without checking every single possible combination? Because let's be real, that would take forever. This exact problem is what the sliding window pattern was born to solve.
You know, at its core, the sliding window is a really simple idea. Just imagine you're looking at a super long freight train, but you're looking at it through a single, small window. You can't see the whole train at once, right? Instead, your window just slides along the track, focusing on a few cars at a time. And that's it. This technique lets us break down a massive, overwhelming problem into a bunch of small, easy-to-manage pieces.
Okay, so there are really two main flavors of this pattern. We're going to start with the first, and honestly, the most straightforward one, the fixed window. And just like the name says, the size of our window is always the same, and it just moves along predictably, one step at a time.
Let's make this concrete with a classic example. The problem is this. Find the maximum sum of any 3 consecutive numbers in this array. So our fixed window size is going to be 3.
All right, first things first. We place our window over the very first 3 elements, 2, 1, and 5. We add them up, and we get 8. Since this is the first window we've looked at, our maximum sum so far is, you guessed it, 8. Pretty simple, right? And now, we slide. But here's the magic trick. We don't need to add up 3 new numbers from scratch. All we do is subtract the number that's falling out of the window, the 2, and add the new number that's sliding in, the 1. Our new sum is 7. Is 7 bigger than 8? Nope. So our max sum stays at 8, and we keep moving.
Let's slide one more time. The 1 on the left drops off, and the 3 on the right comes in. The new sum is 9. And this is the moment. We compare our new sum to our running max. 9 is definitely bigger than 8, so we have a new high score. Our maximum sum is now updated to 9.
And for our very last slide, the 5 gets dropped and the 2 gets added. Our sum is 6. Not bigger than 9, so our max stays right where it is. We've hit the end of the array, so our work here is done.
And there it is. The maximum sum of any 3 numbers in a row is 9. See how efficient that was? By just sliding and making tiny updates, we found the answer without ever recalculating the whole sum each time. And you know, the code that powers this is just so elegant. This one little line is the entire engine. It perfectly captures that logic. Add the new element, subtract the old one, and then just check if you set a new record. It's clean, simple, and incredibly fast. All right, now for the really fun part. Let's level up to the second type, the variable window. This one is way more dynamic. Instead of a fixed size, it actually grows and shrinks based on a set of rules. It's a little more complex to think about, but it is so much more powerful. So just to be clear on the difference, a fixed window has that constant size k. It's your go-to for any problem that asks about a specific length. The variable window, though, is like an elastic band. It changes size, and it's perfect for when you're looking for the longest or shortest thing that meets some kind of condition. So here's our new challenge. Find the length of the longest substring inside ABCABCB that has 0 repeating characters. Notice the key difference here. We don't know the size of the answer. Our window has to figure that out on its own. Okay, so we'll start with an empty window and just start expanding to the right. First, we add A. Cool. Then B. Still good. Then C. Awesome. All unique characters. Right now, our window is ABC, and its length is 3. That's our new max length so far. So we try to expand again. We pull in the next character, and it's another A. Uh-oh. Stop right there. We've found a repeat. Our window ABCA is now invalid. It breaks our no repeating characters rule. So now what? Well, we have to fix it. We start shrinking the window from the left until it becomes valid again. So we kick out the first A. Our window is now BCA. Is that valid? Yep. All the characters are unique again. Great. Now we can get back to expanding from the right. Our max length, by the way, is still 3. And we just keep doing this little dance of expanding and shrinking. We'd expand to get BC, still good, then BCABC, and whoops, another repeat. The C breaks the rule. So we know what to do. We'd start shrinking from the left again until things are okay.
After we go through this whole process for the entire string, we'd find that the longest valid window we ever made was 3 characters long. We actually found it right at the beginning with ABC, but we also saw BCA and CAB. The final answer is 3.
The core logic for this variable window is captured perfectly in this little while loop. This is the shrink mechanism. You can think of it like a bouncer at a club. It just says, hey, while the character trying to get in is already in here, keep kicking people out from the front of the line. It's a really simple rule that keeps our window valid all the time.
Okay, wow. We have covered a lot of ground, from a simple fixed window to this dynamic, shrinking, and growing one. So let's just take a second and wrap this all up by highlighting the most important takeaways.
So here's what you really need to remember. First, the sliding window is your best friend for any problem involving continuous chunks of arrays or strings. Its main superpower is efficiency. It cleverly reuses calculations instead of starting from scratch every single time. And remember the 2 types. Fixed windows are for when you know the size you're looking for, like the max sum of any 3 elements. Variable windows are for when you don't, and they expand and shrink to find things like the longest substring with no repeats.
And that's really it. That's the sliding window pattern. It's more than just an algorithm. It's a whole new way of looking at a big category of problems. Now that this is in your toolkit, the only real question left is, what tricky problems are you going to go solve with it? Thanks for tuning in.